In this series of videos, I'm going to tell you how to compute iterated integrals. In the following video, I'm going to give you an interpretation of what an iterated integral is and actually show you that iterated integrals are going to be the way that we compute multidimensional integrals. For now, we're just going to learn how to compute an integral like this, and like I said, in the next lecture videos, we will see what it means. So an iterated integral is called that because we basically do two integrals. First, we're going to do the inner integral. First, we will do the inner integral and ignore the outer integral. That will give us a function in terms of y, and then we will do the outer integral. So this is going to be the integral from y is equal to 2 to 3, and then I'm going to put in brackets the integral x equals 1 to 2 x squared y dx dy. And I'm just going to do the integral inside the brackets, and I'm going to essentially ignore the outer integral for now. So this is the integral y equals 2 to 3. Now the inner integral is an integral in terms of x. So I'm going to put the brackets here so I don't forget this stuff. But if I do the inner integral, this is an integral in terms of x. And as far as x is concerned, y is a constant. So the antiderivative of x squared y with respect to x is 1/3 x cubed y. And we're going to go from x is equal to 2 to x is equal to 1. So this is 8y over 3 minus 1y over 3, which is just y over 3. This is equal, well, I can factor out a y. So this is going to be equal to 8/3 minus 1/3 y. So 8y/3 minus y/3 is 7/3. So this is 7/3 times the integral y equals 2 to 3 of y dy. Okay, the antiderivative of y is y squared over 2. So I'll write the 7/3. The antiderivative is y squared over 2. I'll write the 1/2. And we're going from y is equal to 3 to y is equal to 2. So this is going to be 3 squared minus 2 squared. That's 9 minus 4. That's 5. And this is equal to 35 over 6. Now we're going to do this next integral. Now notice that this integral is similar to the first integral, but the order of integration is different. So now the y integral is the integral on the inside, and the x integral is the integral on the outside. The process will be similar. So we're going to forget that the outer integral exists. We'll put the inner integral in brackets for now. We're going to do the inner integral and forget about the outer integral for now. And when I say forget, I don't literally mean to forget. We're still going to, we know it's there in the back of our minds, but what I mean is we're just going to do the inner integral without thinking about the outer integral for now. Okay, now the inner integral is a y integral. As far as y is concerned, x is a constant. The antiderivative of x squared y with respect to y is x squared y squared over 2. And we're going to be evaluating this from y is equal to 3 to y is equal to 2. So this is going to be 9x squared over 2 minus 4x squared over 2. And now this is just an integral in terms of x. So this is equal to 5/2 times the integral from x is equal to 1 to x equals 2 x squared dx. The antiderivative of x squared is x cubed over 3. So this is, I'll write the 5/2. I'll write the 1/3. So the antiderivative of x cubed is x cubed, sorry, the antiderivative of x squared is x cubed over 3. That's where the 1/3 comes from. And then we're evaluating from x is equal to 2 to x is equal to 1. 2 cubed is 8, minus 1 cubed, which is 1. And notice this is 5 times 8 minus 1, that's 5 times 7, that's 35 divided by 6. So observe that we got the same answer even though the integral went in different orders. This is actually true. This is essentially true in general for the functions that we're going to see in this class. It's called Penis Theorem. We'll see it below. And in the next videos, in the next set of videos for lecture 28, you will see why this is true.